Welcome back again. Today we're going to talk about the circular therapeutic garden, task number 2, and our student strategy will be focusing on visualization techniques. For their second project part, and their fifth, I was inspired by Therapeutic Gardens Designed for Healing Spaces by Daniel Winterbottom and Amy Wagenfield. This book talked about how gardens and outdoor spaces can be designed to make them accessible for people of all needs. This includes the slopes of ramps, gradients of grassy hills and parks, and even water features placed in front of doors to help people orient themselves with visual and audible cues. And don't forget raised garden beds so that individuals in wheelchairs can still tend the garden, and even secluded areas by terraces or reflection pools for meditation. Alright, well now that we've got some of that introduction out of the way, let's take a look at the actual question. As you can see in the top right corner, I have a picture of a circular therapeutic garden that comes out straight out of that book of Wagenfield and Winterbottom. You can see that it does form a circular path. There are trees, there's flowers, people walking around, some seating areas. I believe there's a terrace there. And we're using this to kind of frame this narrative of what's happening in the actual student problem. You see, they've been given 3 trees only, and they've been told that they have to find the center of this garden if these trees are along the outside edge. Well, for a lot of students, they didn't really know how to begin. Yes, they picked up compasses, but they didn't connect the language with what they had to do. In fact, a lot of them didn't even realize that ABC was going to be a triangle. In the very beginning, some students asked me if they should form the triangle, and I had originally said no, it would be a waste of time, until I realized that actually the majority of students didn't even realize that was possible. Some actually flat out denied that a triangle was going to exist, until I told them to literally connect every single point and then tell me what they were left with. After that, I changed the policy to be, yes, of course, draw your triangle, because I wanted them to know that they can actually see the triangle. Because again, all the work we've been doing for weeks is triangle related. And that was the first step in the visualization process. So we had them draw the triangle, and from there we said, okay, well we have trees. Well, what part of the triangle are these trees on? Well, from there you connect it to math vocabulary. These trees are the vertices. So now students know, okay, time to go back to notes, homework, classwork. They have to figure out where do these vertices of a triangle end up on a circle? What construction do they need? And that was the key part that got them started. Well, in the actual question, it also said, well, once you find the center, go ahead and construct the circle through those trees. And that was a way for them to check their work visually. If their circle didn't go through the 3 trees, then something was off. They could try again. If it did go through the trees, then they were great. They could move on to the next part. And actually, on the bottom of the next side of this part, it asks them to find the circumference and the cost. Well, now that they can see the circle, they have this idea of, all right, I'm placing trees and rocks and bark all around this circular portion. Again, allowing them to visualize what's happening gives them something concrete. It allows them to compare it to what they already know of the real-world experience. So in this particular item, we had them use visualization for identifying trees that form a triangle, this tree triangle, which allows them to form a circle, and then finally, what items need to go around that circle, that distance from the circumference, and then to calculate its costs.